P is being replaced by what it equals in terms of X. Distributing would still be a correct answer for the revenue, but we are going to want that X to be distributed, so we should do that. Woo. So that's our revenue. Whenever we need to find a revenue function, which you will have to throughout this class, we're always going to be taking the number of units we're selling and multiplying it by P, but we need P to be in terms of X. So that's why we did that at the beginning. So our second part of this equation is to find the domain of R. Which is going to be really easy to overthink. So we don't need to overthink it.
We plug in 0 for X.
We don't need to.
Is it just 30?
So the domain should be an interval of X, whatever X is greater than or equal to and less than or equal to.
Would it be 0 and infinity?
Not quite. It is 0 because that's the least number of things that we could possibly sell.
9,000.
9,000, yes, exactly. It comes from what we already know about X. So these equations are building off of each other. So this X that we're using in the revenue equation is the same X that we were using in the price demand equation. So if the price demand equation says that we can only sell between 0 and 9,000 TVs, then we're only going to get revenue from 0 to 9,000 TVs. So our revenue is coming from the sales from that price demand equation. So we don't actually have to do any work here. It just is the same as part A.
Now, will we always get lucky like that, or will it be different sometimes?
Good question.
It will not be different. And I'm gonna say it's not that we're getting lucky, it's just the nature of the revenue function. The domain of the revenue function will always be the same as the domain. Yeah, the same as the domain of the price demand equation.
Positive.
We all need a little luck in math. I like it.
Most definitely.
So we have our revenue function now just by multiplying X by the price and our domain from part A. So now we want to know the marginal revenue function. So marginal means take the derivative of whatever function it's referring to. So what is our marginal revenue function here? Okay, I see it in the chat. That is correct. So we have our 300. The 300x just gets its x taken off when we do the derivative, minus, I'm going to do this in 2 steps just so I can note something. So yes, minus 1 over 15x. On that minus 1 over 30x squared part, that 2 on the x is going to come down and multiply with the 1 over 30, which really means it can just go on the top of the fraction. And then the x gets its exponent reduced by 1. Reduce your fractions. So I wrote this in steps to highlight that this needs to be reduced. It's fine to write it out first like this, but we need to reduce this fraction. So 1 over 15 is correct. And we have our next part is to find r prime of 3,000 and r prime of 6,000 and interpret these quantities. So this is just a matter of plugging in these values. Oops, it's not a 15. That's not supposed to be a 3,000. That should be a 300. Here we go. So if we plug 3,000 into our revenue or marginal revenue function, we get 100. And if we plug 6,000 in,
$200.
200, you said?
Yeah. Oh, 400. Sorry, my bad.
That's okay.
Oh, you put 3,000. You meant to put 6.
Oh, thank you.
You're welcome.
All right. Wait, I'm not getting 400 here. I'm getting negative 100 here.
Yeah, I was just gonna say that too. 400
Oh.
is 6,000 divided by 15.
Yeah,
Oh.
that's the only part I solved.
Yeah, I was like, wait a minute, did I do this wrong? Okay,
I'm waking you guys up. Come on.
you right?
Okay, all right, good, because that's what I wanted to illustrate here. I'm glad it came out to negative 100. So these are our two results if we plug in 3,000 and 6,000. So r prime of 3,000 is 100, r prime of 6,000 is negative 100. So the second part of this question is to interpret these quantities.
I think the negative is defective products.
Nope, it's not defective. So let's start with the 3,000 before we get there.
Is this still E?
This is still E, yes.
Okay.
This is the interpret these quantities part of E.
Okay.
So the 3,000, if we're plugging in 3,000 into R prime, that means at a production level of 3,000 TVs, what is happening? What does that 100 tell us?
That for one more TV, we would get an extra $100.
Yes, exactly. I'm just going to say revenue is increasing by $100 per TV. So if we sell one more TV, if we sell more dollars for revenue, exactly. So what about for the 6,000? What is the negative 100 telling us?
Our
Just that the-
revenue decrease.
Yes, I heard.
Sorry, Matt.
That's fine. So I heard revenue is decreasing, and that is correct. So I'm just copying and pasting and changing these words. So if we are producing 3,000 TVs, revenue is increasing by $100 per TV. So every extra TV we sell, we're increasing our revenue. If we're selling 6,000, or yeah, if we're selling 6,000 TVs, revenue is going to be decreasing by $100 per TV. So I want to just note here that that does not mean that we have like negative revenue. That's not even possible, actually. It just means that our revenue is now declining the more TVs that we add.
Is that because there's typically more discounts when you buy in bulk?
Yes, it comes from the price demand equation that says the more that as demand increases, or as that X increases, the price is decreasing.
Gotcha.
So yes, the price is going down. And so if we look at that revenue function on a calculator, make a new function. Okay. So we had 300 minus 1 over 15. Oh, it was 300x. So our revenue function is, let me increase my x, is a parabola. So our, oh, this should be 30, shouldn't it? I am mixing up the marginal revenue and the actual revenue. There we go. So our revenue function, so this is not marginal revenue, this is just revenue, is a parabola. So when we start selling more stuff, our revenue is increasing and increasing, and it reaches some maximum, but then the price is getting so low once we start selling too much stuff, more things, and the revenue will decrease. So this is what this is telling us. At that production level of 3,000, our revenue is still increasing, but once we get to 6,000, it's actually decreasing. Okay. So we're going to get to part F in a moment, but first I want to talk about one more vocab, which is about break-even points. So far we have talked about cost and we've talked about revenue. Break-even points take both of those into account. So if you're starting up a business, you have a lot of initial costs and not a whole lot of revenue coming in. So things are not starting out well, but then as you sell more stuff, then maybe your revenue actually goes above your cost and now you're making a profit. So the break-even points are those places where we're going from a negative profit, which you're going to say a loss in this case, to a profit or back the other way. So break-even points are the points at which cost and revenue are equal. So on a graph, these are the intersections between the cost and revenue functions. So to find break-even points, you are going to be able to, you can do this on a graph rather than algebraically. So our next question, part F, is to graph the cost function and revenue function on the same coordinate system for x between 0 and 9,000, because we know that's our domain of x. And we will find the break-even points and indicate regions of loss and profit. So we're doing 3 things here, or we'll have 3 parts of our answer.
Is that part of the homework something that can be done in Canvas? Or are we going to have to draw that out?
Oh, you do not have to draw it. That is a good question. If it says to graph, you can just graph it on your calculator or on Desmos, but you don't have to include it in your homework. If you want to make a little sketch just for illustrative purposes, you can, but it's not required.
Okay, perfect. Thank you.
So we're going to find the break-even points, and we'll find where we have loss and where we have profit. So if you are using Desmos, I want to do this both on Desmos and on the TI calculator, just so everyone can see how both work. If you are using a TI but not Desmos, then you can sort of ignore the Desmos part, or if you're using Desmos and not the TI, you can do the opposite. So let me just change my share real quick to Desmos again. So I have already put in the revenue equation. And again, just in case you haven't used Desmos very much, that little wrench in the top right corner lets you change the X and Y axis. So that X, we could start at 0 and go up to 9,000. So that's what we're doing, just so we can see the exact domain. If it's a little off, that's okay. It doesn't need to be perfect. And then the Y will need to be adjusted just so you can see everything. And then also put in the cost function that we had. Oops. Okay, there we go. That wasn't right. Okay, I forgot what the cost function was apparently. 150,000, that'll change it. So if you are plus 30x, if you're using Desmos or a TI, go ahead and start to put those in and try to figure out the break-even points and the loss and profit. I am now going to switch my share to a TI calculator so we can see.
What are you using for the Y values? For the X-axis or Y-axis?
I just sort of zoomed in and out until I got there, but this is going up to, it should be at least roughly, that's almost 800,000 at the top. Y could start at 0. It's just wherever we can see the whole graph. So on a TI calculator, so if you are using a TI, go ahead and open it, and in this Y equals, so if you haven't used one much before, we can go to this Y equals on the upper left corner, and that is where we can put in two functions. So I'm going to clear that. We can put in our revenue function, which was 300x minus 1/30 x squared. And our cost function was 150,000 plus 30x. So once we get those two, the revenue and cost equations in there, if I just go straight to graphing, the window is probably not right. The standard window is 10 by 10, and this is way off of that. So if we want to change the window on the TI, we go to Window, which is all of the graphing buttons are on this top part. So if I just go to Window, I can change X to be 0 to 9,000. That's our domain. And the scale is just where the calculator puts little tick marks. And so I'm just going to put 1,000 just so there aren't very many. That doesn't really matter. Y, neither our cost nor our revenue is going to ever be negative. So I'll just start at 0 for the Y. And we just saw on Desmos that Y was going up to about 800,000. If we don't know exactly, we might just have to do a little bit of guessing and checking, or try to plug in some numbers into our revenue function so that we can see how big it's getting. And I'm going to put 100,000. So once we have that and we graph it, we can see our graph.
For some reason, my graph looks different than yours in Desmos. I don't know if I'm typing it in wrong.
How does it look different?
Can I share my screen?
Yes, let me stop sharing and then you should be able to.
Okay, let's see.
So your cost function is the one from the very first example and not the one we're on now. So that was the transmission cost function and we are looking at the
see.
TV cost function. Also,
Okay, so that would be X 9000 minus 30p.
that was the price demand equation. We have a lot of functions going on here. So the cost function was 300 minus 150,000 plus something, plus 30p. $30x, excuse me. Yes. And then the revenue should actually be 300x minus, and then it's 1 over 30x squared. Yeah, so try zooming out or changing your Y so that it goes up to about 800,000 and that should fix it.
I feel like I had the same problem as you, man. And yeah, you just have to fix the actual parameters. But my graph looks just like just like it was supposed to now. Like I was having some problems with that earlier.
Yeah, it can be tricky to get the window all set, but yeah, that looks like it should now. It's just the windows.
Okay.
Perfect.
My screen is like completely frozen. I can't do anything right now.
Oh, okay. Well,
I will try it, but
okay, yeah. That's okay. Okay, I'm gonna I'll bring my screen back. So I'm gonna go back to the TI real quick, just to talk about intersections here. We did a little bit of this, I think, in the very first review assignment, but on the TI to do intersections, all of the sort of graph things are on this calc, which is right above the trace. So if we do second trace, there is number 5 says intersect. So if I select that, it asks for the first curve and second curve. So it wants to know which 2 graphs we want to intersect. So if we had more than 2 graphs, that would matter, but here it doesn't. So I can just hit enter on the first curve and it automatically jumps to the second one. So if I hit enter, enter, guess is nothing, we don't need that. And it'll go to this intersection. So that means that one of our break-even points is 7,500. And I need to be writing this down. So I'll share my screen in a little bit with this written down. So 7,500, 375,000. So that's one of our intersections. And if you're on the TI, we have to go through that same process of second trace for calc, intersection, and then we just have to scoot the cursor closer to the other intersection, which can take a little bit, but we just need to make that little bug move closer. And it doesn't have to be like right on it, it just needs to know which intersection we are trying to get to. So now I'm closer to the other intersection and I can do that same enter, 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 and it'll jump to the other one. So our other break-even point is 6,000 or 600, 168,000. So are there any questions about the TI at the moment before I jump back to Desmos? I just realized I lost my chat screen when I switched my share. So let me just check. Okay. All right, so I am gonna change back to Desmos. Desmos is more user-friendly. It's just kind of quicker to find the break-even points. My mouse is struggling. There we go. So on Desmos, Desmos kind of automatically gives us important points. So even if I'm just hovering near the intersection, it automatically brings up that 600, 168,000. And I can click on it also if I want it to stay highlighted. And if I move over to the other intersection, that's also there. So if we're graphing on Desmos, finding those break-even points is just a matter of like clicking on the intersections and it'll tell us exactly what they are. So this does take a little bit of practice, just getting used to like adjusting the windows and everything. So as you're doing your homework, let me know if you're having any issues. Google is also a really good resource for TI calculators. There's about 1 million videos and things about everything. So if you just Google like TI-84 intersection, lots of information will pop up.
I have a quick question for you, Madeline.
Yes.
If we like, probably for you, I'm not sure if it's memorized your like patterns or whatnot, but when you exit out, will it keep those same like the same like y-axis and x-axis values, like, or are we gonna have to reset them every time that we open up Desmos? Like I don't even want to close mine now just because it's kind of at the right thing, but I didn't know if that changes.
Yeah, if you close Desmos and just open Desmos back up, it will not save it.
Okay.
So if you're working in one problem, I would recommend not closing it.
All right, pro tip. Thank you. Thank you.
Actually, too, man, when you put in a new equation, sometimes it changes your settings too. So just kind of watch out for that one. It did that to me too.
Yeah.
Got me mad because I had it all set up and then it reverted back to the old thing. I was like, come on, I just.
Yeah, see, I don't know. I'm willing to type it back in. I just don't want to get to the point and then be like, oh, wait a minute. Oh, I'm looking at something wrong. I don't want that to happen.
Right.
You can actually save the URL of your graph and come back to it later.
True that.
You can.
So
okay.
at the top of the screen, it says share your graph, and it says share this link, and you can copy that, and that'll bring you back to your graph.
It sure does. Okay, man. All right. I need to check this out more. Thank you. I appreciate that. That's actually a good resource right there.
That is.
And I never tried like creating an account either, but I think you might be able to like have a bunch of graphs saved if you log in, maybe.
Yeah, it's asking me to do that too, sign up or log in, and I'm like, yeah, I don't know. But if it saves graphs, that might be worth it. Right. All right. Thank you guys. Appreciate it.
The home button and it brought me back here. So yeah, there's all sorts of stuff. Thank you for that help, Lucas. Okay, so we have our two break-even points, which are just those intersection points, and make sure the break-even points are both the X and Y together. So let's look at profit first. For what X values are we making a profit? I'm going to bring the graph back.
From 600 to 7,500.
Exactly. So our profit is happening when revenue is higher than cost. So if we're bringing in more money than we're spending, we will have a profit. So starting at that 600 and going up to 7,500. And for, sorry, is it already 115? Oh, it is 10. Okay. So profit is starting at 600 and going up to 7,500. Loss is all of the other parts, and we just have to be careful that, oh, I don't know why I changed, sorry. Now I'm panicking. Loss, we have to make sure that we're staying within our domain. So loss is happening starting at 0 and going up to 600. And then starting at 7,500 and going up to 9,000, since that's our highest possible X. And those could be written in interval notation as well. I just put them in algebraic notation for no particular reason. So we're always working within our domain between that 0 and 9,000, and we're just breaking up these two little end bits are where we have a loss because cost is higher there. And then everything in the middle is where we have a profit since revenue is higher. And those breaking points come directly from the break-even point. So those X values of the break-even points are telling us where we change from loss to profit and from profit to loss. So we are out of time, and I'm going to post the rest of the homework for this week about this section 2.7 in a little bit. I also just want to mention, if you have to leave, that's fine at the moment, but I want to mention that in the week 5 module are 3 things about the test. So there's an information guide about how to, the procedure of the test. There is a review sheet, which I made that has some information, or like all of the sort of key points and key vocab words. So if you have any questions as you're going through this, please let me know. And of course, it's not loading now, but it really is in there. It's just my internet. And there is also the practice test, which I posted earlier this week, and I will also post the answers to that so you can tell if you're getting the answers right or not. So we are out of time, so if you have to go, feel free. If you have any questions, then don't hesitate to ask now, and I'll see you next week if not.
Thank you, Madeline. Have a good weekend.
You too, thank you.
Have a good weekend, Madeline. I will see you next time.
Sounds good. Oh, there was no in-class assignment. I need to delete that because we didn't get to it. So, well, there are submissions. Yeah, nothing to turn in today.
For the test next week, it's during class hours, correct?
Correct,
Okay.
yes.
All right. I'll have to